Hello class, welcome to the next segment in the week 3 material, and in this segment we're going to take a look at what happens when you put three numbers in the range function when you're using the range function as part of a for loop. So in this case, in the previous case when we had just two numbers, we specified a starting value and an ending value, which the ending value is not an inclusive bound, so we start at the starting value and then go up to but not including the second number that's specified in the range function. And by default, that process will be something that increases by 1. So in the case of our looping variable, which is the same one we had in the previous segment where we had the variable I will start off being 0. And when there was just two numbers, then I would go up to 1, then to 2, then to 3, until it gets to its maximum value. In the case of, but when you put a third number in the range function, you specify what you want the computer to count up by as the loop progresses. So in the case of our looping variable I, in this case, I will start off at 0, then go up to 2, then to 4, and then so on and so forth until we achieve the maximum value. And again, I'm going to use the same tables that we did before to sort of get an idea on what we expect the program to produce if we were to run it as it is. So again, I will start off being 0. So the first time through the loop, I will assume a value of 0. And then following the rules that we've laid out here, or how the computer is going to interpret this, now the next value that I will assume will in fact be 2, because this third number in the range specifies how much I want the computer to count up by as we go from one cycle to the next in the loop that we have. So I will start off at 0, and then the second cycle, the second time through the loop, I will now assume a value of 2, because now we're counting up by 2 every time we go through the loop. And then the third time through the loop, now we go from 2 to 4, again counting up by 2, just taking the previous value of I and adding 2 to it, so we get 4. And then the next cycle through the loop, the fourth time through the loop, we get a value of 6 for I. We take the value 4 that we had left over from the previous cycle, add 2 to it, and we get 6. And then the fifth time through the loop, we get a value of 8 for I, and just like before, I does not assume this value of 10. Just like before, this upper bound is not inclusive, which means we start at 0, go up to but not including 10, counting up by 2 every time. And since we don't include this value of 10 here, then the loop stops after 5 cycles. After 5 times through the loop, I will assume a value of 8. If it tries to add 2 to this again, then we go to 10, but we're not supposed to include 10, so as such, the loop should in fact terminate. So based on the logic that we've deduced from this table, if we're telling the computer to print out what the value of is after going through the loop every single time, through every single cycle, then if we were to run this program as it is right now, we should expect the program to print out 0, 2, 4, 6, 8. So let's see if that's what we in fact get when we tell the Python program to run this. So if we run this program, we can see we do in fact get 0, 2, 4, 6, 8, and again, this 10, this upper bound is not included in the output here, because the looping variable, in this case I, will never assume this upper bound here. It will assume the value that's just below that upper bound, which in this case is going to be 8. So that's one example of range function that utilizes three different numbers. That again, those three different numbers are separated by commas here. So in summary, you can read this off as start at this value, take your looping variable, whatever that is, start at this value, go up to but not including this value, counting up by this value every cycle or every time you go through the loop. So for the sake of understanding, let's go ahead and take a look at a second example. And here I'm going to be using a different looping variable, but I could reuse I again if I really wanted to. And let me actually go ahead and I'll actually go ahead and ask you to sort of check your understanding. I'll go ahead and ask you to pause the video and try to fill out the table yourself, just based on all the information that you've been given up to this point. Try and deduce what the value of x is going to be at each cycle number, at each point throughout the loop's progression. So I'll give you a few seconds to accomplish that, or to attempt that. So hopefully the end result looks like what you're about to see on the screen. So again, this is our looping variable x, and again we have two columns because we only have two relevant pieces of information that we're really interested in as it pertains to our loop. So first time through the loop, when our cycle number is just 1, our variable x, so x is going to start off at this value right here. So the first time through the loop, x is going to have a value of 0. And then the second time through the loop, when the cycle number is 2, then since this third number is 10, that means this old value of x is going to get 10 added to it when we go to the next cycle. So the second time through the loop, x will go from 0 to 10, since this value in this third value in the range is in fact 10. So counting up by 10 every time. And then the third time through the loop, x will go from 10 to 20, again just simply counting up by 10 from the previous value of x. And then the fourth time through the loop, we will go from 20 to 30. And then the fifth time through the loop, we will go from 30 to 40. The sixth time through the loop, again just adding 10 to the old value of x, we will get a value of 50. And then the seventh time through the loop, we will go from 50 to 60. And then the eighth time through the loop, x will assume a value of 70. Ninth time through the loop, x will assume a value of 80. And then the 10th time through the loop, x will assume a value of 90. And again, just like before, this upper bound is not inclusive, which means the variable x is never going to assume this exact number right here. So this loop should in fact stop when x is equal to 90, because if I add 10 to this value of x right now, that will be equal to 100, but we're not supposed to include 100 when we're going through this loop, because this upper bound here is something that's not inclusive. So let's get some confirmation of that. Let's see if that is in fact what this program would give us if we were to run it right now. And if we launch this program, we see first x is 0, then it's 10, then 20, then 30, and you can see this does in fact match up with what we expected. The highest value that x is, in this case, is in fact 90. So just in case I didn't say it before, if you have range with just 2 numbers, then it's sort of implied that this third number in the range is 1. So it's just implied that you only want the range to count up by 1 every time. And one thing that might also be worth mentioning is here, this upper bound is something that's a multiple of the third number, but that doesn't necessarily have to be the case. In fact, I could say for x in range 0, 101, and if I were to do that, then now there's actually a chance for x to assume a value of 100, because now 90, if I add 10 to 90, that's 100, which is still not including 101. So that is a way that I can include the value of 100 here. I can make this 101, even though this isn't an even multiple of this or a whole number multiple of this, it's still something that a computer can act on. So if I wanted to, again, include some sort of upper bound, I could do that using 101. I could also do that using 110 in the case of this loop, since this third number is 10. I can do anything from 101 to 110, but if I try to go one higher, say 111, then I will pick up a value of 110, which you can see over here. So again, this something that's really important to keep in mind, especially as you're building loops. The second number that you put in the range here is the looping variable, in this case x, is going to go up to, but not including the second number. So that's just something very important to keep in mind when you're going to build some sort of loop using building some sort of loop in Python. But that's going to do it for this next segment on loops. And in the next segment, we're going to take a first look at something referred to as a while loop, or the idea of conditional repetition. So with that, I will see you all in the next segment.